In this video, we're looking at the 2022/2023 chemistry test questions and answers. Okay. Now, note that the questions are not very clear, so all you have to do is to increase your video quality to the maximum so you can see the questions clearer. Also, I'll be reading out the questions to help you get them better. Okay. All right, the instruction here says tick good in the box containing the correct answer. All right, so your instruction is to tick this good in the box containing the correct answer. Now let's look at the questions. Question 1 says a matter is anything that has mass and occupies space. Which of the following is a matter? The first thing there is idea. Next up you have light. Next up you have air. Next up you have shadow, and then you have heat. Between idea, light, air, shadow, and heat, which of these is a matter? The answer there is air. So I'm going to tick good in air. All right, so air is matter. All right, air has mass, and air also occupies space. All right, so air is the answer. The other ones are not matter. Right, an idea is not a matter. Neither is it light, shadow, nor heat. All right. Question 2 says the answer for the computation of this in the correct significant figure is, now let me write out the number you have there. The number you have there is simply 4.23 plus you have 6.1 all divided by you have 4.218. All right, and they ask you to compute this to the correct significant figure. Now if you punch this with your calculator, your answer will give you something that looks like 2.44902 797 then 5. You'd have this from your calculator if you punch it, right? 2.44902 7975. You have this. All right, when they say to the correct significant figure, how do you get the correct significant figure? Now all you have to do is to take the lowest significant figure from your given values. For instance, if you look at the numerator, you have the first value there, 4.23. For 4.23, you have 1, 2, 3. You have 3 significant figures. So I have 3 significant figures for the first value. Next up, you have 6.1. That becomes 1, 2. So you have 2 significant figures for 6.1. Then the last thing you have there, which is your denominator, you have 4.218. That becomes 1, 2, 3, 4. You have 4 significant figures. So it becomes 4 significant figure. So out of this, observe that our least value is 2 significant figure. In essence, this will be equal to, I'll just pick out 2 significant figure and my answer would be in 2 significant figure. So that becomes 2 and 4. Right? Of course, 4 is a plus 0, not a plus 1. So it becomes 2.4. My unit is in centimeters, so it becomes 2.4 centimeters. So if you ask to present your answer in the correct significant figure, what you use is the least significant figure from your given values. So my answer is 2.4 centimeters. And if I look at this, that's the first option there, 2.4 cm. That's the first option. All right, so that becomes my answer. The third thing you have there, question 3 says, the universe was formed by a massive explosion that propelled matter into vacuum. This statement is classified as, the first thing you have is experiment. Second thing you have there is hypothesis. Next thing you have there is scientific law. Next thing you have there is qualitative observation. Next thing you have there is theory. The answer to this question is theory. All right, this theory is called the Big Bang theory. All right, so the answer there is theory. Question 4, you're given a particular diagram here. I will draw it out. It says the diagram below depicts visualizing concept of the transformation of matter. What is the name of the process of B? That's the question. Now let me try to draw out this. You have solid on the left hand side, gas up, and then liquid on the right hand side. So you have solid. So what you have is this solid. You have gas. You have liquid. All right. Now let's look at the direction of the arrows there. Solid to gas is A. Gas to liquid is B. So solid to gas is A. So you have A running this way. Gas to liquid is B. So you have this, and then liquid to solid is there. So this is A, this is B. So the B you're asked for is simply from gas to liquid. All right. When gas changes to liquid, what's it called? It's called condensation. All right. The change of state that involves the conversion of gas to liquid is called condensation. Now, moving from liquid to gas, the change of state of matter, where something moves from liquid to gas, of course, is called evaporation. Of course, it's called evaporation. From liquid to solid is melting, right? While from solid to gas, straight up, is actually from solid to gas is called sublimation, right? Meanwhile, from gas to solid straight up is called deposition. Okay, so please take note. When something moves from gas, from the gaseous state, directly to solid without passing through the liquid state is called deposition. So you can make your own research about things like this. It's called deposition. Meanwhile, in the question, we are asked for B, and B is simply the movement from gaseous state to liquid state, and that's called condensation. So our answer for that one there is condensation. So you can see your option there: condensation, deposition, which I've explained, evaporation. Evaporation is when it moves from liquid to gaseous state. Melting. Melting is from gaseous to um, melting is from solid to liquid state, and then sublimation. Sublimation is from solid to gaseous state. So from here, the answer is condensation. All right, that's your answer. All right, number five. Number five says cathode ray experiment is related to all of the following except, right? Cathode ray experiment is related to all of the following except. Now, the one that's wrong here, that's not related here, is neutron, right? In cathode ray experiment, J.J. Thomson used zinc sulfide. He used electrons. He used evacuated tube. He also used voltage, but not neutrons. So the answer here is neutrons. So please take note. Number six also says, which of the following is not a polyatomic ion? Right? A polyatomic ion is an ion that is made up of several atoms of either the same or different elements. The first one there is O2, 2 minus. The fact that you have two, O2 means you have two atoms of oxygen, so it's polyatomic. Others too are the same thing except Hg2 plus. Hg is actually mercury. So we have Hg2 plus, it means just one atom of mercury. So it's not a polyatomic. Instead, it is a monoatomic. So I'll choose Hg2 plus. It's a monoatomic ion. The others are polyatomic. Number seven, the oxidation number of manganese in potassium permanganate is KMNO4. So you have this KMNO4. You have to find the oxidation number of manganese. Now, how do you find this? First things first, for potassium, you have K plus, right? The oxidation number of potassium is +1, so it becomes +1 plus. For manganese there, for manganese, we don't know it, so we call it X. It becomes X plus. For oxygen, the oxidation number is -2, so it becomes -2 times the number of atoms. That's 4. That's 4 is equal to 0, right? Equated to 0. Since this is a neutral atom, it has no charge. There's no charge here, so you equate to 0. If there was a 2 minus here, you equate to -2, right? So if there's a charge, you equate it to the charge, but there's no charge, so you equate to 0. This becomes 1 plus x plus -2 times 4 is -8. It's equal to 0. So I have 1 plus x plus minus is -8 equal to 0. Working on this, 1 minus 8 is -7 plus x equal to 0. Move this over here, you have that x is equal to +7. So the answer is +7. Let's see which option is that. So your options there are 0. You have 0 plus 4 plus 7 plus 6 plus 5. The answer is +7. So I'm taking +7 as the correct answer. Let's look at number 8. Number 8 says the electronic configuration. This contradicts. Now look at what we have here. What does this contradict? The problem we can see is that for the sp cube, you have something of this nature. Let me draw this out. You have this, this. And if you look at the number of electrons here, we have, for the first one, we have 2. We have 1 here. We have 3 electrons. And on a normal state, if you know how this is done, you first of all fill them independently first, like 1, 2, 3, singly first, before you now take them as pairs. So they should have been arranged in single electrons before we take them as pairs. That's the problem here. But in this question here, they took pairs, that's 1 up, 1 down, and then this. In essence, all the atoms were not filled singly first before they started doing their pairing here. Right? And this contradicts which principle here? The answer there is Hund's rule. Right? The answer there is Hund's rule. Now, Hund's rule, according to Hund's rule, it states that electrons occupy each orbital singly first before electron pairing takes place. So before you even start pairing electron, you have to occupy them. So I'm saying this. If I have 3 electrons to be imputed here, I must first of all, let's say I have 3, it must be 1, 2, 3, right? So it must be this way. I must first of all fill them singly first before I start taking a pair. So if I had 5, it would have been 1, 2, 3, then 4. All right. Before I did this pair, I had first of all filled this singly first. So that would now have been 4, and then perhaps I would have another one here, then 5. All right. So before you take them as a pair, you must first of all fill up all the orbitals singly. And this question, this part here, fails to do that. What they gave us in the question was this. They gave us this and they gave us this one here. Right? So they were already pairing electrons even when they had not filled this singly. So the answer there is Hund's rule. So I'll just come here and choose Hund's rule. All right. So Hund's rule is your answer. Let's move on. Number 9. In the electromagnetic spectrum, which below has the highest energy? That's the question, right? In your electromagnetic spectrum, which of the options have the lowest energy? That's the question here. And from the options, we have microwave, radio waves, ultraviolet rays, X-rays, and infrared. Now let's take this. Let's note this. In the electromagnetic waves, we have the following. Number 1, gamma rays. All right, let's call it gamma first. Gamma rays. Number 2, we have X-rays. All right. Number 3, we have UV lights. UV lights. Number 4, we have visible lights. Let's call this visible lights. Number 5, we have infrared. We have infrared. Number 6, we have microwaves. So we have microwaves. Number 7, we have radio waves. 7, we have radio waves. All right. Now, from this arrangement now, the highest energy is in gamma rays. All right. So if you look at energy from here, let me do it this way. From here, I'll just bring this down. Do it this way. In terms of energy, the maximum energy is possessed by gamma rays, while the most minimal energy is possessed by radio waves. So that's what's to note. That's one. Number 2 is wavelength. In wavelength, it becomes the opposite. So I'll come here and I'll do this. Right? Let me do this. So wavelength, this becomes minimal for wavelength. This is maximum. Let me call this wavelength. That means the one with the highest wavelength, the one with the highest or the maximal wavelength is radio waves, while the one with the most minimal wavelength is gamma. Going back to the question here, we asked for which of them? Highest energy. All right, the highest energy should have been gamma, but there's no gamma there. So we have between microwave, radio, ultraviolet ray, X-ray, infrared. After gamma, which is the maximum energy, the next one becomes what there? X-rays. So my answer should be X-rays. Highest energy from here is X-rays. So I'll come to X-rays and I'll take this. All right, the answer there is X-ray. All right, make sure you don't tick outside the box. All right, your ticking should be within the box. All right, that's done. Number 10 says the electronic configuration of the outermost shell of an atom of an element is 3s squared 3p to the power 4. Right? The atomic number, group, and period of the element in the periodic table is. Now, how do you solve this particular question? Our first task would be to write this in full. Don't forget they said this is what the outermost shell, right? So let's write this in full. If you know how the SPDF configuration works, let's write it out in full. It will help us get the answer. Don't forget you have 3s squared, 3p4. Before 3s squared and 3p4, what should have come first? Let's try to get that. Now, when it comes to SPDF configuration, of course, the first thing we have there is 1s squared, right? In full, we have 1s squared, and then we'll now have 2s squared, and then we'll have 2p to the power 6. So we'll have this one first before we now have the outermost shell as 3s squared and 3p to the power 4. I taught this concept in our previous class. So go to the search button or go to the channel, check the playlist and look for the inorganic chemistry playlist. Now go down, you see the video on how to do SPDF configuration. Now back to this, we are asked to find what's there. The group, you're asked to find the word there. Atomic number, group, and period. How do you get atomic number? We get atomic number by adding their powers. The power here is 2 plus 2, that's 4. 4 plus 6, that's 10. 10 plus 2, that's 12. 12 plus 4, that's 16. So atomic number 16. So I'll write this down. Atomic number is 16. Now, how do we get the group and period? Now, that's also simple. For us to get group and period, we have to use the KL-MN shell concept. And if we do for 16 we have the K shell as 2, all right? The L shell would be 8, then the M shell would be 6, all right? Just simply this 1, 2, and then this one here, you'd have 1, 2, 3, 4, 5, 6, 7, 8, and then your final shell will now be 6. So you have 1, 2, 3, 4, 5, and 6. All right. Now the period will be equal to, let's see, period. Your period will be equal to number of shells. I have 1, 2, 3 shells. That's the K shell, the L shell, and M shell. Period is 3. What about the group? The group will be equal to the valence electrons. That's electrons on the outermost shell, which in this case would be 1, 2, 3, 4, 5, and then 6. So have this. All right. So atomic number would be 16. The period would be 3. And the group would be 16. So let's see which of them is that. So the group will be 6, please. And the group would be 6. All right. So let's see, group 6, period 3, atomic number 16. All right, that's the second one here. That's 16 for atomic number, group 6, and period 3. That's the second one here. So that's your answer. All right, let's go to 11. 11 says, the diagram below shows the reaction of reactant A, that's white spheres, and reactant B, black spheres. The equation that best describes the reaction is, so here's your reaction. Let's take a good look at this. So if you look at this, they said the white spheres represent reactant A. Now, how many white spheres do we have here? We have 1, 2, and then 3. We have 3 white spheres. But observe that the spheres come in pairs. So since they come in pairs, it becomes an A2. They come in pairs. And we have 3 of them. So it becomes 3A2 plus also the B, that's the black spheres, also come in pairs. And I'm looking at 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 of it. So 9 of the black spheres, so 9B, but they also come in pairs. So it becomes 3A2 3A2 plus 9B2, right? Okay, that's probably either this or this, but let's continue. Our answer here, what does it give us? So for my answer here, if you look at this, look at one of this, right? What I have there is simply something that looks like this: one black, one white in the middle, one black here, and then a third black here. So for each of these, I have three blacks, okay? That's B3, and one white, that's A. So it becomes AB3. That's it. So A means one white and then three black atoms. With this, I have about 1, 2, 3, 4, 5, 6. So it's 6 of this. It becomes 6AB3. If you look at that, 6AB3 is, let's look at this, 3A2 plus 9B2 to give you 6 atoms of AB3. That's this one here. Alright, so this is my answer. Alright, so that's how I get the answer, okay? Okay, so let's look at the next question, question 12. The question says, the light blue glow given off by mercury street lamps has a wavelength of 436 nanometer. What is the energy in joules? Okay, you have the wavelength, this as equal to 436 nanometer. All right, write this in terms of meters. That's equal to 436 times 10 to the power nano is minus 9 meters. Now record that energy E is equal to H times F, where H is actually Planck's constant. But then in terms of the speed of light, we know that speed of light c is equal to F times lambda. From here we can have that lambda is equal to this, divide this by, right, so if we have this, we can divide this by wavelength and divide this by wavelength to get frequency. In essence, E is equal to Planck's constant times frequency becomes C all over lambda. This is still correct. So with this formula, let's get the value of H, Planck's constant. So if you look at this, given as 6.63 times 10 to the power minus 34. So I would come here, H is 6.63 times 10 to the power minus 34. Then C is the speed of light, 3 times 10 to the power 8 all over wavelength is given in the question as 436 times 10 to the power minus 9. So you get your calculator and punch this correctly. If you punch this correctly, your answer gives you about 4.6 times 10 to the power minus 19 joules. Alright, 4.6 times 10 to the power minus 19 joules. And if I look at this, what's the option there? So you have the option here as 4.56, okay, times 10 to the power minus 19 joules. Okay, so you have something like that. That's what you have here. So 12, your answer becomes this one here, 4.56, which is approximately 4.6 times 10 to the power minus 19 joules. So I'll take that as my answer. Okay, number 13. The question says, the planetary model of hydrogen atoms was contributed by who? The answer to that question is near Bohr. So I'll choose Bohr instead. So I'll just come here, I'll tick Bohr. That's the answer. 14. The name of the molecular compound is, you have Cl2O3. It's just simply, when you have Cl2, it's dichloro, not chlorine. Right? Cl is chlorine, but it's dichloro, not chlorine. Then 3 is tri. Alright? Then you have O there. So it becomes dichlorotrioxide. Alright? Dichlorotrioxide. Of course, that becomes this one here, dichlorotrioxide. 2 chlorine, 3 oxygen. That's the answer. Number 15 here, the next one. 15 says the compound formed by the reaction of potassium ion and a hydrogen phosphate ion, that's this is, so let's see that. So potassium ion is K plus, that's K plus, combining with hydrogen phosphate ion, which is given as HPO4 2 minus. What will be your answer? Now, if these combine, when atoms combine, what happens is that their paths come down. So the 2 minus the 2 here comes down here. That becomes K2. Then this one here I have HPO4. The power here is a +1, so nothing changes here. So I would have K2 HPO4 as my answer. So K2 HPO4, that's this option here. That's your answer. All right, 16. 16 says magnesium has 3 naturally occurring isotopes with masses 23.99 atomic mass units, that's AMU, 24.99 atomic mass units, and 25.98 atomic mass units. And the natural abundance of 78.99%, 10.00%, and 11.01% respectively. The atomic mass of magnesium in AMU, that's atomic mass unit, is, well, that's simple. For each of them, the first thing you have there is 23.99 AMU. It becomes 23.99 times, multiply that by the percentage abundance. For 23.99, the first value it has there would be this one here, which is 78.99%. That becomes 78.99% divided by 100. That becomes 0.7899. Right, 78.99% is simply 78.99 divided by 100, and that gives you 0.7988. 7899, please. Plus, next I have 24.99. Right, so I'll have plus 24.99 multiplied by the abundance there is 10%. That's 10 all over 100, which gives you 0.1. Then plus the next thing you have there would be 25.98. So it becomes 25.98 times the percentage abundance here is 11.01. So divide 11.01 by 100, it becomes 0.1101. So you have this. All right, so this is now equal to, I'll just get my calculator and punch this. So let's see this. Give me some minutes. All right, punching this, I have the first bracket. I'll type in 23.99 times 0.7899 plus I have 24.99 times 0.1, then plus, open the last bracket, I have 25.98 times 0.1101. My answer is about 24 points. Okay, let me encase this in brackets. All right, my answer is 24.31 approximately. All right, 24.31, 24.31 AMU. So which option is that? 24.31, 24.31. All right, I can see the answer there. This one here. That's the correct option. All right, the next one there. Use the following to answer questions 17 to 20. All right, let me clear this first. So I'll clear this and let's do 17 to 20. All right, let's see this. So we said, they said, when tin comes in contact with oxygen in air, tin 4 oxide is formed. The balance equation for the above reaction is, that's a question. Now, how do you get this? The first thing you have to notice is that tin is Sn and Sn is monoatomic. Of course, tin is a solid, so it becomes this as solid plus, they said comes in contact with air, or with oxygen in air, so it becomes oxygen O. Oxygen is diatomic, that's O2, and it should be in gaseous state, so O2 gaseous state. They said it forms tin 4 oxide. So what's the formula for tin 4 oxide? Tin 4 oxide is actually given by SnO2. That's tin 4 oxide, and this is usually a solid. So this becomes the answer. So let's see which option rhymes with this. SnSO2 gas, then SnO2 solid. All right. Let's see this. I think this is already balanced. It's already balanced. Okay, so we already have an answer. I think that's the first one there. Just trying to confirm this, and then yeah, the first one there. This is the correct answer. All right. All right. So that's the correct answer for this question. All right. Next up, please. Next one says, if a piece of tin foil 8.25 centimeter by, this is times means it's called by because we're dealing with dimension here. 8.25 centimeter by 21.5 centimeter by 0.0600 centimeter, right? They give the density as 7.28 gram per cm cube. Is exposed to oxygen. The mass of tin foil, right? So we want to get the mass of tin foil. They give you this one here. What you're given here, this value shows the dimension, and from this we can calculate the volume. All right, so we can get that the volume for 18, the volume V, it's equal to 8.25 in centimeters multiplied by 21.5 in centimeters multiplied by 0.0600. If you multiply all of this, it's centimeters times centimeters times centimeters, which is centimeter cube. And that would be 8.25 multiplied by 21.5 multiplied by 0.0600, and this gives you about 10.64. That's about 10.6425. 10.6425. You have this value in cm cube, right? Cm cube. This gives you the value of the volume. They give you the density rho as being look at it here. This value here, 7.28. So you have density as 7.28. You're asked to find the mass. Now we know that mass density rho is equal to mass over volume. This is all over 1 such that mass times 1 is mass. So mass is equal to density times volume. That becomes rho V. And it's equal to density is 7.28 times the volume. The volume there is 10.6425. Let's multiply this. This gives you 10.6425 multiplied by 7.28. And if you multiply this, the value gives you about 77.48. 77.48 in grams. That's the units there. So let's see, we have anything like 77.48. We have 774.8. No. Okay, so we can see 77.5. So that's our answer. Right. If I approximate this, it's approximately 77.5 gram. And that's what you're given here. So the answer here is 77.5 gram. That's it. All right, before we look at the next question, let me clear this space. All right, let's do number 19. Number 19 says air is about 21% oxygen by volume. They give you density there as 1.309 gram per liter. They also said the liters of oxygen required to completely react with tin would be what? I think that's the question there. Our first task is to get a formula, right? The formula or the equation of the reaction is simply tin, that's Sn in solid, reacting with oxygen, O2 in gaseous state, to give you tin 4 oxide, that's this, also in solid. Alright, so that was like the equation of the reaction. Okay, so before we sum 19, let's take out what we've been given. Okay, first things first, we already have the mass. What we have there is mass of tin, the mass of tin, Sn. Let's call this mass of Sn. We got the value as 77.5 in gram. Also, looking at what we have here, they also give us the density, right? They give us the density here as 1.309. That's the value of the density there. So let's call it the density. Now, also looking at this, it said air is about 21% oxygen by volume, and then the density of oxygen here is 1.309 gram per liter. So take that density of oxygen, density of O2, it's equal to 1.309 gram per liter. You have this. Okay. What's the first thing to do here? Our first task is to get the mole. Let's get the mole, or the number of moles of tin. Now we know that mole is equal to the mass of tin, whose value is 77.5. That's the mass of tin. Mole is equal to mass all over the molar mass, or the atomic mass of tin. If you look at the top right here, you're given that the atomic mass of tin, look at it here, 118.7. All right, so all over 118.7. So let's get this value here. So if you punch this will give you about 0.68 0.6527 moles. All right, so divide the mass from the previous question, 77.5 gram, by the molar mass, or the atomic mass of tin. You have this one here. So that's what you have here. Now, what's the next thing you do here? All right, so from here, let's get the molar ratio. From what we have here, if you look at what molar ratio here, we have 1 mole of tin, because you have one here, is to 1 mole of oxygen, because you have one here. That's your molar ratio, is to 1 mole of tin oxide. All right, so if you look at the molar ratio, we would have that for tin, Sn, and oxygen, O2, from the balance equation of the reaction, you need a mole of tin to react with a mole of oxygen. Now, from the given question there, or from our mass, we've gotten the mole of tin to be 0.6527. What will be the equivalent mole of oxygen for this particular mole of tin? What will it be? Well, it's as easy as cross multiply. 1 times x gives you x is equal to 0.6527 times 1 will be the same thing here. That means we'll have that x is equal to 0.6527 mole of oxygen. So we have this. We're not asked to find the number of moles of oxygen. No, we're asked to find the what there? The liters of oxygen. Liters means volume. We're asked to find volume. So that means that we have to find the volume of oxygen. And how do you get volume there? We know that density, rho, is equal to mass all over volume. And if this interchange, we'll have that volume. If I make volume to be subject of the formula, volume will be equal to mass all over density. We're already given the density of oxygen, as you can see in the question. We were given the value of the density of oxygen. All we have to find is the mass of oxygen. Now, if you have this as the mole of oxygen, what would be the mass of oxygen? We know that mole is equal to mass all over, let's call this molar mass. The mole value we got here is 0.6527. The mole of oxygen is equal to the mass of oxygen. What's the mass of oxygen? It's unknown. Let's just call it M then O2. Mass of oxygen all over. The molar mass of oxygen would be, now we have O2 here. For an ordinary atom, that's O, the mass is 16. Since you have O2, it becomes times 2. That's 2 atoms. From here, we'd have that this is all over 1. Mass of oxygen times 1 gives you mass of oxygen. So hence, we can say that the mass of oxygen, that's MO2, will be equal to this times this, which is 0.6527 times 16 times 2. So let's get this down. Let's get this down and see what we get. From here, it becomes 0.6527 times 16 times 2. Our answer here will be equal to, what do we have here? We have 20.8864. All right, of course, in grams. We've gotten the mass of oxygen. We're asked to find the liters, number of liters, all right, which was the volume. And we said volume is equal to what there? Mass over density. That's equal to the mass from the question here is 20.8864. So we have this as 20.8864. That's the mass all over. The density from the given question was 1.309. So all over 1.309. If I do this, I'll just get my calculator. 20.8864 20.8864 divided by 1.309. My value here is about 15 point approximately 96. 15.96 approximately in liters. So which option is 15.96? Let's see. 15.96. Okay, we don't have any 15.96, but you can see that we have something that looks like 15.98. All right, we have a 15.98. So it could be that maybe because of the decimal place I use. So I'll go with 15.98 liters of O2. All right, the difference could be because of my number of decimal points approximation. That's why. So I'll take 15.98 as my answer. Okay. All right. The last question there, number 20. Number 20 here says the molecules of tin 4 oxide formed if 10 gram of the solid tin foil is reacted with 2.10 gram of pure oxygen gas is, you have to find the molecules, all right, or the number of molecules. Let's get the complete equation of the reaction. We have tin Sn as being solid plus oxygen O2 in gaseous state to give you SnO2, tin 4 oxide in solid state. Okay. Molar ratio is 1 is to 1 is to 1. That's the first thing you have there. Given the mass, you're given the mass of tin as 10 gram. So if you're given the mass of tin as 10 gram, what would be the number of moles? The mole or number of moles of tin is equal to the mass of tin 10 all over the molar mass of tin. Again, given here is 118.7. So all over 118.7. Let's divide this. This becomes 10 over 118.7, and that's about 0.084 approximately 25 mole. So I've gotten the mole of tin here. Okay, I said what would be the number of molecules of this? Our next task will now be to find the number of mole. So mole of oxygen O2, and that's equal to the mass of oxygen here is 2.10, so it becomes 2.10 all over the molar mass of oxygen molecule. That becomes 16 times 2 as we did earlier, which is 32. All right, so 16 for just O, then O2 becomes 16 times 2, and that's 32. All right, let's get this value here. This is equal to, now in getting this, that becomes 2.1 all over 32, and that's equal to 0.065 6 approximately, right? Or let's say 63 approximately. This is the number of moles of oxygen. Now look at the question very well here. You asked, said the number of molecules of tin 4 oxide formed if 10 grams of tin reacts with 2.1 gram of pure oxygen. So I'm working with tin 4 oxide, then that's S1, that's SO2, tin 4 oxide, that's SO2 here. Now the question is this. All right, so we are here. My next task, going back to the question, we are asked to find the molecules of tin 4 oxide formed when 10 gram of solid tin foil reacts with 2.10 gram of pure oxygen gas. Now the thing is this, I'm going to be using tin oxide and either one of tin or oxygen, right? So which will it be? Will it be tin or will it be oxygen? All you have to do to know which to use is to look for the limiting reagent, right? So this is a question on limiting reagent and then excess reagent. So for these two here, we'll look for which of them is the limiting reagent and which is the excess reagent. And how do we get that? I'll compare tin Sn with oxygen O2. From the balance equation of the reaction, we can see that we need 1 mole of tin to react with 1 mole of oxygen to form tin oxide. Now, if I have, from what I have here, if I have 10 gram of tin, that would result in 0.0842. That's 0.08, is it 24? 425, all right, 0.08425. And if I have 0.08425, the number of moles of 0.08425 of tin, this would also need exactly the same amount, that's 0.08425. In an actual sense, right, if 1 mole of tin is needed to react with 1 mole of oxygen, then 0.08425 mole of tin will also be needed to react with 0.08425 of oxygen. But looking at this, from the available mass, we have just 2.1 gram of oxygen, and that translates to 0.06563 moles. What does it mean? It means that this value is not sufficient enough, because this value here is less than, what I have here is lesser than the required volume. In essence, this becomes what there? The limiting reagent. Why? It's not up to the amount of moles I would need. So it becomes the limiting reagent. And in solving this question, you'd always take the limiting reagent and then the one you're asked to find. So I'll pick up the limiting reagent, which is O2, and then we're asked to find the number of molecules of tin 4 oxide. Right, so this is how, and then for this we have SO2. So we're asked to find the number of molecules of tin 4 oxide, that's this, but then we're given two masses, one for tin, one for oxygen. The task is simple. Look for which of them is the limiting reagent. And for you to get which is the limiting reagent, you first of all have to find the number of moles of each of them, which we've done here. We got this and this, and from our analysis, it's seen that the number of moles of oxygen is insufficient, right? It's insufficient, so it becomes the limiting reagent. So I'm taking up the limiting reagent and tin 4 oxide. From here, we know that from a balanced equation of the reaction, 1 mole of tin 4 oxide needs to react with 1 mole of tin 4 oxide. Okay, so from this, let's get the number of moles of tin 4 oxide. From here, we can see that what's available there is 0.06563. So hence, we'll have that the available mole 0.06563 of oxygen would need to react with how many moles of this? We'll call it X. Right, from here, without even stressing ourselves, if 1 is 1, then X should be equal to this, or you can say cross multiply if you want to. That means X will be equal to, without stressing ourselves, X will be equal to 0.06563 moles of SO2. So you have this, okay? So if you can work with this, or you can say cross multiply, you still have the same answer. Now, note that in the question, you're not asked to find the number of moles. No, you're asked to find the number of molecules. And what do we know? We know that mole is equal to mass all over molar mass, but at the same time, it's also equal to number of particles. All right? These particles could be molecules. So when they say find the number of molecules, in this case, the number of particles becomes molecules. That's how this is done, right? Molecules all over Avogadro's number. Okay, let me write this better. Now, if that's true, I'll take this off. Put this here. So number of particles. The number of particles in this case, the particles becomes molecules. So when they say find the number of molecules, it's simply number of particles. So number of particles, I'll change this to molecules as requested in the question. So number of molecules all over Avogadro's number. Again, Avogadro's constant is given in the top question here. You can see the Avogadro's number 6.02 times 10 to the power 23. So this all over Avogadro's number 6.02 times 10 to the power 23. So if I ignore this, we can see that this is all over 1. If I ignore this, it becomes number of molecules times 1. That becomes that the number of molecules will be equal to the number of moles times 6.02 times 10 to the power 23. The number of molecules there we got is as will be equal to the number of moles times this. The number of moles we got that as 0.06563. That's the number of moles of tin oxide times Avogadro's number. Avogadro's number is 6.02 times 10 to the power 23. If I multiply that, right, multiplying that, what do I have there? I'll get my calculator and punch that. If I punch that, my value will be equal to 3.95 times 10 to the power 22 molecules. So this is the number of molecules, all right? This is how we solve this question. Let's see which option gives us that. 3.95 times 10 to the power 22 molecules. That's this midsection here, this one here. That's your answer. So basically, this is how we solve this question, okay? All right, so guys, if you enjoyed this video as usual, please do well to hit the like button. All right, so like this video, leave a comment. If you enjoyed this video, tell us in the comment section. If you have a question, ask in the comment section. Also, don't forget to subscribe. If it's your first time here or you're yet to subscribe, please do well to subscribe to this channel and hit the bell icon so that you get notified whenever we upload a new content. Then finally, share this video to your friends so that they can also learn. Don't forget to visit my website. Don't forget to visit my website www.jonahemmanuel.com/courses to get any of the available courses, or visit www.jonahemmanuel.com/books to get any of the available books. All right. Do want to create an account with the website and then proceed to get any of the available courses or books. Thank you and see you in our next class.